Hello student, today I am talking about electric flux. Electric flux is very important topic for 12th board, JEE main and NEET exam. Electric flux, basic concept of electric flux, this is the phi E equal to E vector dot A vector. Okay, now from dot product of two vectors, EA equal to cos theta, where theta is the angle between E vector and A vector. Suppose this is a surface area. This is the surface area. Surface area directed here. This is the A vector. And electric field directed here. And this is the theta angle between. This is the surface area. Surface area of this surface is A. This is the vector quantity. Area vector simply area vector. Suppose that this is the surface like a square, side A and A. This surface is placed in XY plane. This is the plane XY. So area vector equal to A square K cap. Because area vector always perpendicular to the plane. Plane is X and Y. X and Y is a plane. This is the area vector. So result will be A square. Suppose that you have a cube. This is the cube. Side of cube is A. Now consider three-dimensional axis. This is an area, this another area, this is another area, and this is another area. One area towards you and another area inside the board. Total area, surface area equal to 6. Total surface area equal to 6. Now consider this is the first, this is the second, this is the third, and this is the fourth. And fifth towards you, and sixth towards inside. So this is the 5 and this is the 6. Okay, first right here, this is the area towards x-axis. Because this plate, this square directed towards x-axis, because this square is placed in YZ plane. Like this. This is the YZ plane. This is YZ plane. This is y-axis and z-axis. So area towards here. This is the two surface area, right and left. Right and left. If observer towards here, area here plus A and opposite of A1 is minus. Similarly, area vector towards this. This is A2 vector, this is A3 vector, and this is A4 vector. Another vector A5 towards you and A6 inside the board. Clear? A1, this is the A1 vector is equal to A square minus I cap. This is the area vector. A2 vector equal to A square and plus J cap. Again, only I cap. A3 vector equal to A square minus I cap. Because A3 vector is just opposite of A1 vector. So this is positive, so negative. And again, A4 vector is opposite of A2 vector. So A4 vector equal to A square minus J cap. Again, A5 vector equal to A square K cap. A6 vector equal to A vector minus K cap. Now net area vector, net equal to 0. This and this will be cancel. Again this and this cancel, this and this cancel. So net area vector equal to 0, but net area equal to A square, number of phase 6. 6A square. Net area. Area never 0, but area vector 0. Okay, so this is the area vector concept, most important for calculation of electric. Example, Example first. This is like this cross-sectional. This cross-sectional area vector or electric field directed towards this. This is the electric field. This is the electric field. This area directed here, this is the A vector. And this area directed, this is also A vector. Clear? This cross-sectional area and this cross-sectional area are similar. So, magnitude of A, this cross-sectional area is A, and this cross-sectional area is also A. This is a curved surface, this is the curved surface. Okay, curved surface area vector like this, perpendicular. A dash. This is the A dash. Yeah, A1. Okay. Now, net flux will be 0. Net flux will be 0. This is A vector dot E vector. Any problem? This is A vector dot E vector. Any problem? This is a curved surface. A1 vector dot E vector. Now, for this, direction of A vector and E vector are similar, so A into E, right here. Now, electric field directed from left to right, and area vector from right to left. So C minus A into A. And this is A1E cos 90. Cos 90. This is 0. Cos 90, 0. Again, EA minus E into A plus 0, 0. Net flux 0. Net flux 0. But each flux, this is the positive flux, and this is negative flux, and this is the 0 flux. Okay. Net flux 0 for any closed body. For any closed body. Clear? Now, suppose that we have to calculate electric flux this curved surface here. In terms of, suppose that electric flux for electric field in terms of component. This is K cap. So now phi E equal to this will be result simply from dot product. Okay. Now another concept. For calculation of electric flux is Gauss law. Gauss law. Net flux for any closed body is equal to net charge enclosed is multiple of 1 by epsilon naught. Now phi net Q enclosed divided by epsilon naught. Very important law for calculation of electric flux and electric field. Very important. this is simple example. Finite Q1 plus Q2 divided by epsilon naught. Flux for this closed surface. Now flux for this surface, finite equal to minus Q plus Q equal to 0. Finite equal to 0. It means that number of field lines in is equal to out, because magnitude of charge are equal. Now phi 3 equal to finite equal to Q1 plus Q2 epsilon naught. This charge will be neglected because this is outside from the Gaussian surface. Now this is example, very important example. Not charge inside, charge placed here. What will be flux? What will be the flux? Okay. So now we consider like a Gaussian. This is a spherical Gaussian surface. Okay. The finite is equal to Q divided by epsilon naught. Finite equal to Q divided by epsilon naught. Now E into A. This is a finite. Consider number of symmetric surface. This is 1. Same surface here 2. 1 and 2. This is a number. Finite. Each flux. Sorry. Phi each. We have to calculate flux through this surface. The phi each equal to Q divided by epsilon naught into 2. This is the answer. This is the answer. Because here is the number of symmetric surface. Number of symmetric surface equal to 2. Similar. This is Q placed at the center of the cube. Okay, so we have to calculate flux through this surface. First write phi net equal to Q divided by epsilon naught. Phi each Q divided by N into epsilon naught, but in cube N equal to 6. So phi each flux through each surface is equal to Q divided by 6 epsilon naught. Because cube having 6 number of symmetric surface. 6 number of symmetric surface. This is a solid sphere. Charge plus Q charge distributed uniformly over the surface or inside the surface. Okay. Now we have to calculate magnetic field intensity at that point P out, and at that point P on, and at that point P in, and at that point P center. First we consider radius of sphere capital R and another distance small r. Small r is the distance from center of a sphere to the point where we have to find electric field intensity. Clear? Step first. Find net flux. Step second. Find net flux, that is from GAUSS. Second, find net flux from formula. Step third, equate both equations. Okay, now the solution. Question is very simple and very important. We have to calculate electric field out, on, in, at center and graphical representation of electric field intensity versus R for the solid sphere. Clear? Step first, like this. Plus Q charge distributed uniformly. Okay, this is the point outside. Consider a Gaussian surface like inside the body. Inside body is a spherical, so Gaussian surface is also. Consider electric field generated from a sphere like this, but not goes outside due to Gaussian surface. Consider a small elementary parts here. This is the delta A area vector. This is the delta A area vector and electric field E. So flux will be here. Flux from here. E, this is the E and delta A. Okay? Again delta A, again delta A, again delta L, again delta L. Okay? So phi net. Phi net is equal to E and this is summation delta A. Initial to final. So this is the area of a sphere 4 pi r square. Any doubt? Phi net is equal to E out because point is out and 4 pi r square. This is equation number first. And phi net, we have studied Gauss law. Q divided by epsilon naught because this is enclosed surface having the charge Q. This is the second. Step third, equate both equations. We get result. So now, this is a small r. Capital R is the radius of a sphere. So here, we use a small r. This is a small r. So from first and second, E out into 4 pi r square Q divided by epsilon naught. E out is equal to Q divided by 4 pi epsilon naught into R square. Any doubt? Student, your homework, this is the homework. E on equal to Q divided by 4 pi epsilon naught into Q divided by the capital R square. How can you write here? How can you write this result? Now, a small r becomes capital R when point comes on surface. Any doubt? This point comes here. R is equal to R. Any doubt? So this is your homework. You have to calculate like this. Okay. Again, inside. Inside is very important. Inside. Suppose that this point is inside. This is the point P inside. First, we have to consider like this the Gaussian surface. Okay. This is Gaussian surface. This is a small r. Okay. So first we have to calculate Q enclosed. Very important. First we have to calculate Q enclosed. Similarly, E in equal to Q enclosed divided by 4 pi small r square. So now, first this is equation number first. Now 4 by 3 pi r q. This is the volume contain charge Q. Overall volume of a sphere contains charge Q. So in unit, so in 4 by 3 small r q is equal to Q into 4 by 3 pi small r q divided by 4 by 3 pi capital R q. Any doubt? This and this cancel. This volume contains Q enclosed. So here we can write Q enclosed, and this is Q This is Q into RQ divided by capital RQ. Very, very important. Q enclosed. Now Q enclosed is equal to Q small RQ divided by capital RQ. So E in, this is E in equal to 1/4 pi epsilon naught small r square into Q RQ divided by RQ. This and this cancel. So E in equal to 1 divided by 4 pi epsilon naught into QR divided by RQ. This is important result. Now R equal to 0, E center equal to 0. Because R equal to 0 means that point at the center. So at the center of solid sphere, electric field intensity is equal to 0. Now graphical representation here, very simple. To represent the graph between electric field intensity versus distance. Now inside directly proportional R. This is constant quantity. Again, capital Q is the constant quantity and capital R is equal to constant quantity. Only R vary point to point. At center R equal to 0 and continuous value of R increase. So electric field inside R, inside sphere increase. So very simple to represent the graph between E versus R. E versus R. This is the center. This is the center of a sphere, like here. This is the center of a sphere. Suppose that this is the sphere. Okay? And this is the center of a sphere. Here electric field equal to 0, R equal to also 0, electric field 0. Again R increase. This is small r equal to capital R. So right here. This is electric field inside. This is on the sphere. This is the maximum electric field. Again 1 by R square. Okay? This is the out 1 by R square. Out 1 by R square and inside directly proportional. R so a straight line and here 1 by R square graph. This is the representation. This graph and this graph, this line and this graph is parallel. So it will meet at the infinite. This is E out. This is E in. Okay, this is small r less than capital R. This is R is equal to R. This is the point. And again, small r greater than capital R. Very important graph. This graph is important for board, JMain, NEET as well as advanced. Okay.